Okay, for anybody who's just joining us or joins us sometime between now and the next 55 minutes, there's not going to be anything on this video. I'm pretty sure I'm not going to do anything. So what you can do is just forward exactly 55 minutes, and that'll bring us up to 9 o'clock on the clock you see in front of us, or front of you, here at 9 p.m. Eastern Standard Time. I'm doing this because it gives time for lots of people to see that this is being broadcast live so they can join us. I have found that if I wait to the last minute, like 10 minutes before the hour, not a lot of people get on board. But if I start the live broadcast well in advance, then I get lots of people that get on board. So I'm trying to be thoughtful. It's a Friday night, and a lot of people out there just, they go out and they go party, whatever it is that they do. There's a lot of us old farts that are getting older and older, and we don't go out and party anymore. So anyway, so I wait till 9 o'clock. Seems to be a pretty good time. Maybe I should do another one at tomorrow night, Saturday at 9 o'clock. This is going to be about stripping VCRs, because what happens is with these VCRs, they got lots of great parts in them. Capacitors, MuMetal plates, which is what I've done is I've put out a call online for people to donate their broken down VCRs. And I'm starting to get responses. So VCRs are slowly but surely starting to come in the door. It's great. So that's going to work out really nicely. I'm not sure how many of these VCRs actually have metal plates in them that are made of MuMetal, but the only way to find out is to start stripping these things. So, okay. Okay. If you've never ever been to my channel before, this is the first time, but you're here because of your interest in magnetics. What I have been all about over the years and what I've been advocating is that it's possible to use metal as shielding to control or shape the flux of magnets. So we can shape it and control it in such a way that it becomes favorable to get a desired action and reaction. There's two actions, the initial reaction and the secondary action. It's the secondary action is the most important one because, as some of you may remember, Newton said in his third law of motion that for every action there is an equal and opposite reaction. Well, I found a way to defy, overcome, or prove that that law is not always correct. So, and also you have to remember that was back in the late 1700s. That's a long, long time ago when Newton came up with that reasoning that he strongly believed in. Well, when Newton came up with that third law of motion back in the 1700s, late 1700s, maybe it was the very, very early 1800s when it became public, that he didn't have the kind of technology we have access to today. So, and his logic seems very logical. I mean, it does make sense. But I came up with a very simple way to get around that law, a way that he just never really stopped to think about. And that is what would happen if you could create an imbalance. Because his theory or law is based upon everything is balanced. So for the same amount of force on one side, you get the same amount of force on the other side, but opposite. Thus the term for every action is equal and opposite reaction. So in the world of magnetics, that plays a really big role. I mean, his theory plays a really big role. Now, I say theory because he really, I don't know how much testing he could have done back then, because we had very limited technology back in the 1700s and early 1800s. So here I am now in the 21st century, as they call it, even though it's 20000, not 2100. But this is the year 2019 now. Long ways from the 1700s, back in the 1790s. Okay, so again, if you're just joining us and you want to see what's going to go on here with this VCR, and looking for parts and to see how successful of an adventure this is, then, just forward it to where you see 9 o'clock here. Get it to say 9 o'clock here, the big hand up here, and that's when I'll start. Okay, I'm just cleaning up my desk right now, all this junk. I've been away for a couple of weeks. I apologize. I do have another life that I live, and soon I'll have more free time, a lot more, but that is not yet to happen. And I will eventually have more funds again, and so I'll be able to buy the things that I need. Hopefully, maybe at some point, I can bring a magnet maker on board. Maybe they might have interest in sponsoring a major project. Kind of quickly recap. I'll use this as a deck. Can you see that good? Here, maybe not. Right. There we go. Let's see here. I guess we'll use these two Wii controls here to illustrate what it is I'm talking about. Okay, let's see here. Newton's law says that if this is, let's say this is a magnet, and then this other remote for a Wii is a magnet, okay? And I could use real magnets, but the trouble is they'll slam into each other. So let's say this is a magnet, and this magnet is fastened. It cannot move. And then we have this other magnet here that we are going to move. Okay, now let me turn this imaginary magnet. This is the imaginary magnet. And let's turn it this way to the camera. Okay, and now we have here is the other imaginary magnet. Okay, what Newton's law is telling us is that if this magnet is stationary and this magnet is on a wheel, like my bicycle wheel that I use, that when this magnet, when the attraction of pull pulls this, it comes and accelerates and goes right by this magnet. But Newton's third law of motion, or attraction, says that this magnet will also receive the same equal counterpull. Well, technically he's right so far. So what happens is that when this swings by here, say 6 inches, it comes by here, and about 6 inches or a little less, it stops and becomes counterpulled. The counteraction pulls it back, and so it goes this way. It swings out here, and then on this side, the counterpull or counteraction pulls it back. So what happens is that this goes like this, like the pendulum on the clock. However, each time it swings back and forth, the swing gets smaller and smaller and shorter to a point where it finally comes to a rest. That's Newton's third law of motion or attraction. Okay? What I have done is that it's so that this side is weaker. It's not as strong as this side. That means when the magnet on the wheel goes past the stationary magnet, a stationary magnet is called a stator. The one that's moving is called an armature magnet. So when the armature magnet goes past the stator magnet, instead of the equal force that Newton's third law of attraction talks about, that would normally pull this back, it would stop it. So it would go here, come out to here, and then it would suddenly come to a stop, and then come back. With my setup, the armature magnet approaches the magnet, it accelerates, of course, and then as it comes out here, it does de-accelerate. It does lose motion, but it doesn't lose all of it. It only loses some of it. So that means that when the armature magnet comes by here, it goes out and it just keeps going. With Newton's third law of attraction, that is not supposed to happen. Now, over the years, people who live, breathe, eat, and live by their physics books believe, are completely convinced that any videos that I have posted so far that shows my magnet approaching the stator magnet that keeps on going has all been fake. I want to have you all know, some of you anyway, who leave little snippety comments about I've edited these videos. Every once in a while, there's an upload glitch. I can't help it. There's nothing I can do about it. So sometimes you may see a single glitch or sometimes multiple glitch. The last video I put up, it had like 3 or 4 or 5 glitches in it. And it makes it look like I was editing the video. I'm not editing anything. The only time I edit my videos is when I put in text, especially in the beginning or end or credits, or in the middle of a video, I might completely bring the video to an absolute stop, insert some additional information, and then we'll pick up where the video left off. But I never create any kind of edits in the middle of an actual experiment, because then that raises doubt, and I don't want to do anything to raise doubt. Okay. Anyway, that's my story, and I'm sticking to it. This is some of the MuMetal that I got out of the other machine the other day. Now, you don't need to use batteries anymore, the dead batteries. I did that out of desperation. When you're trying to jerry-rig stuff together, you grab anything you can find in your garage, in the kitchen, maybe even in the trash can. I pulled out a couple of fruit cans, juice cans, and I remember the experiment with the lid, tin lid, and a paper clip on a thread and a magnet in high school back in, I don't know, 73, 72. Anyway, what it showed is that the teacher had a paper clip on a thread and the magnet up here. The magnet was up here, thread was down here. The paper clip could not reach the magnet, but the invisible magnetic field held the paper clip in place. So what she did, she took the lid and interposed it, put it between the magnet and the paper clip. And what do you think happened? The paper clip fell back down. So that meant the shield, the tin lid, acted as shielding to help block or deflect the magnetic flux of the magnet. So I never forgot that. So that was the basic premise of my approach to my experiment. I also want to let you all know, if anybody's still just kind of hanging, listening, that I did not do this through trial and error and experimentation. It simply dawned on me. I realized how this could be done. And the moment I realized this cannot be that hard to do, within about an hour, hour and a half, I had bent, cut metal, shielded magnets in such a way, and then stuck a bunch of magnets on a wheel to a configuration that seemed to make sense. And then I tried it. And the very first time I ever tested my what was then a theory about that it would be possible to overcome Newton's third law of attraction, I did it instantly. There was no trials and errors. I immediately saw the problem, walked up to my desk, started bending metal, having some fun with magnets and whatever, and about 2 hours later, total time, I had it working. Now, what I didn't have is that I didn't have the actual wheel running around and around in circles yet. I wasn't that far along. I had to make 4 stators and then place them all the way around the wheel. Well, I had only built 2, and I didn't know it would kind of work. And it was trying to work. It was trying to spin on its own. So I was tired. The video was rolling. I had 2 cats in the room. You can see the cats in the video. I just gave the wheel a spin, and I disappeared, went down to the kitchen for about, I don't know, 20 minutes, maybe 30. I don't really know how long it was. And during that time, the wheel apparently was still spinning. I didn't know that. So I came back up, saw the wheel was still spinning. I went, wow. Started the camera, wanted to make sure I got this on film. And next thing I know, my cat, Sky, an incredible young man, the cat, Himalayan flame point cat, started playing with the wheel. And if you watch that video initially, when Sky, the cat, starts playing with the wheel, he puts his paws on it. If you look real carefully, watch the speed of the wheel. And after he starts to put some reasonable friction on the wheel does not slow down. Then he decides he wants to keep playing with the wheel. And I just, I didn't care. I thought it was interesting. So he leaned into the wheel a little bit more with a little bit more friction. And yes, finally the wheel started to slow down. But then he started playing. I thought this was amusing. And he played with it. And then he got the wheel to basically stop. However, the wheel was starting to start up again. And so Sky decides he's going to put his paw on it, and now the wheel really truly does stop. Well, that's basically the end of the video right there. After that, I never got back to pursuing the matter further because of a chain of events that happened in my life. So initially, when I had my very first amateur, I mean really crude setup, it was on the floor, it was laying on its side. I had magnets attached to furniture, an end table. I think another one was to a brick or cinder block, places where I could, tape my stators to hold them in place. Remember, when you're just doing things on the fly, you don't care how it looks. You're just trying to prove theory. And if it works, it's no longer theory. So I've got it to work. And it was working nicely. I was like, wow, this is really awesome. I never pursued the matter as far as really putting it all together on a more practical level. I mean, really building something that's appropriate and a proper way to do it. But I did post the initial first video, and you can see where it was running. And I didn't make the video really long. I think I only made the video like, 5, 7 minutes. It was under 10, I'm sure. And back then, you couldn't make more than 10-minute videos anyway on YouTube, unless you, broke them down and posted them up at multiple. So, hang on a second here. So, when I put that video up, in about 2 weeks, I think it got over 1 million views. I really don't remember anymore, but it was a really big number. It got hundreds of thousands of views, and within about 2 weeks, YouTube took down the video, say violated their community standards. Of course, that was garbage. I think what happened is that people believed the video was faked, and so people flagged it. That was the early days when YouTube started introducing people to the ability to flag a video. That way YouTube didn't have to police it, they let the public police the videos. So anyway, people thought it was fake. So I put it back up one last time, and maybe 3 or 4 days later, and this time the video got taken down again, but this time in like, a week. After that, I didn't bother to put it up again. I had 2 strikes against me, and YouTube warned me that if they have one more strike against me, they account for a period of time or close the account. So I didn't put it up again. But I did put up some other videos that still proved what was going on. That account got closed pretty quickly after that. So I started another YouTube account. And they even banned me from surfing YouTube. I got banned, literally banned from surfing on YouTube. And I'm thinking, that's crazy. So I found a way around it, and I set up a similar account. And now we have this channel here, and so far I haven't gotten any warnings at all. I'm surprised, actually. I think it's because YouTube may have done away with this flagging system or changed the algorithms on it. Because in the past, you had what I refer to as cyber gangs. And there was a group of them. And they would go around to any and all channels that had anything to do with magnetics. Pushing the limits on what magnets can and versus what magnets can't do. At least what most people understood back then. So I noticed that numerous channels got shut down. I'm not so sure if it was YouTube itself doing it, though. I just think it was people ganging up on videos saying this has to be fake. And so that's what got me shut down, because too many people reported me as faking my videos. And I didn't fake anything. People reported it as a scam. Well, last time I checked, when you're trying to scam somebody, scam is when you get something from them in return based upon a lie, deception, or just whatever. I just know that providing information up on YouTube, and I'm not even monetizing my videos. I'm not receiving any funds. I'm not asking for any funds. And I don't have anything for sale. I like that one day to change. Once I get things up and running properly and I've got an actual prototype that's working beautifully, maybe I'd like to sell the plans to it, or better yet, just go into production. Find somebody who wants to back me. This is way over my head, let me tell you that. All I have done is found a way around Newton's third law of attraction, or motion, and nobody else has. Now, there are other motors online, other magnetic motors. I don't know if they're fake. I don't know if they're real. The trouble is, at least all of the many hundreds of videos I have checked, I have yet to find any video where they truly break down and explain in detail how they do it and how we can replicate their work. I mean, really show exactly what is going on. And a lot of these videos, they won't even talk. They won't even open up their mouth. And that makes me suspicious right away. And you don't get to see underneath the table. And I'm thinking, well, why don't they just walk outside? Take these small devices that they're holding in their hands, just walk around outside. Because then they're not near any devices that could be hidden just off camera. Anyway, it's 27:30 till 9. I may leave here in a minute. Go use the bat room, see what Robin's up to. The MuMetal, by the way, even though we can use this good old-fashioned flashing that I've been using, the MuMetal, it's less. We don't need to use as much material, so it allows us to make the stators more compact. Now, I don't know if you're seeing my video for the first time. Hang on a second here. Let me show you what a stator is. Really, what you need to do, if I've caught your attention, leave the video at some point and just go do some research. Google stators and learn what stators are, and learn what armature magnets are, and kind of just watch some videos on it. I can't always educate everybody all the time within every video what's going on. Every video would be just insanely long, like 2-3 hours every single video. So, but I'll just tell you a little bit here. I'll show you what a stator is. And that's why if you look here, it says James Roney Stators. Why not call it James Roney Stators? When you have the Van de Graaff generator, named after Mr. Van de Graaff. I mean, it's just logic has it that when an inventor, I don't even believe in inventions. I believe all of us, none of us are inventors. There's no such thing as an inventor. There's not a single inventor on the entire planet. As crazy as that sounds, it is the truth. I don't know how the word inventor got started, but really what's happening is that we're not inventing. We are discovering. We are realizing how things can be done. Science is an endless row of discoveries. Nobody invented science. Nobody invented magnets. Magnets are around since the birth of the earth. We simply figured out how to improve upon the magnets that are here and create better magnets than that of what nature makes. So I don't believe there's such thing as inventors. All of us so-called inventors are simply everyday people who make discoveries. So I'm not an inventor. I'm just somebody who discovers how things could be done. And I realize I always have this belief that I share with people that learning is a very slow process. Some things we want to learn takes days, weeks, months, even years. And some things we love to learn, we can't because life is just too short. But what if we could realize how something's done rather than learning how something is done? And that's the journey I started on back when I was about turning 19, when I started realizing that philosophy was actually valid. I went from blowing on a mouth harp and sounding so bad that nobody dared wanted to be around me, to when I was driving down the road, when I stopped to think, how is a harmonica structured, a mouth harp? I don't have one here to show you, but it's a harmonica. You put them in your mouth, you blow it. So I gave it some thought for about a whole 10 seconds. And then it came to me. I realized how I need to be playing that mouth harp. In less than 10 seconds, or thereof, I went from sounding like a total idiot on a mouth harp to somebody who could play a pretty badass mouth harp almost instantly. In fact, I was so proud of my accomplishment that I was not too far away from Ocean City, Maryland. When I arrived there, remember I'm about 1918, I had a great set of lungs. I was an athlete. When I hit that boardwalk, I started playing that song I realized to play. It was a whammon jammin' type song. It was really badass. And I would walk up and down the boardwalk playing as hard and as long as we could. And people just gathered all around me, clapping their hands and dancing. And I walked up. Those people who were started with me, they dropped off. I picked up new people. They were dancing around me as I kept walking up the boardwalk. They would finally drop off. As I walked up further, pick up new people. I'm still playing the same darn piece. It's about a 2-minute piece over and over again. And by that time, about a half hour later, I was done. I couldn't do it anymore. My lungs were tired. But that was my first experience in the process and the reality of realization. The ability to realize how something can be done. And I've been using that strategy ever since. And so that's how I came across, now, gets back to what we're talking about here. I realized in an instant, less time it took me to explain all this to you, how we could defy or get around Newton's third law of attraction. It just came to me. So I didn't do any experimentation. I just put it together and it worked. So this here is my stator. This stator meaning it's a magnet and it just stays stationary. I built this one last week. The magnet on this is wrapped around. This is MuMetal. And this magnet here is too far forward. It needs to be recessed further back, about a ½ inch. So anyway, this is a stator. And so I built this about 6, 7, not this one, about 6 or 7 years ago. In fact, the original stator I built is right here. This is the original stator I built about 6 years ago, maybe 7 by now. And this is what started all the controversy online. This simple stator I built with the concept that I shared with you is what started all the hullabaloo, or all the controversy. And I can't emphasize enough I haven't faked anything. I don't need to. People who fake things is because they can't get things to work the way they want them to work, or the way they believe they should work. And it's not to look bad or stupid or faking things. Or more so, the reason a lot of these videos are faked is not so they will not look bad, it's so they make money because they monetize their videos. And so they're trying to get thousands of views, hopefully hundreds of thousands, or even millions. I've had, I think I'm over 5 million views now on my channel. And I haven't made a dime because I never bothered to monetize anything. Because I'm not trying to make any money. Hindsight, I wish I had, but the other side of the fence is it's a good thing I didn't. Because then it would add fire or fuel to the fire that people believe that I've been faking all of this. Because then I'd have a reason to fake it, because I'd be making money. But I'm not making any money. Okay, what else here? I'll be back in a few minutes here. For some reason, YouTube is not showing me who's here. It didn't happen last time either. I couldn't tell who was here. Somebody said how I could tell. Let me see if this is how I can tell. Nope. It says all messages are visible. Okay. Anyway, this will be here. It says some people are here apparently. If you're just joining me here at 9 o'clock, I'll be back and we'll start. So what we're going to do here is we're going to have some fun. I put out a call for people to donate VCRs, and people are starting to donate them to me. And so what I've been doing is taking these apart and seeing what I could find in them. And the last VCR I took apart, I found big plates of this. This is MuMetal. Just phenomenal. Just amazing stuff. So we're going to take this bad boy here apart and see if there's anything in here. Now this machine feels really light. So this machine may be one of those super low cheap machines they manufacture. It's not about ready to put in a big plate of MuMetal in here. But they still have to protect the tape head from the natural magnetic fields generated by the circuitry and also natural fields that are around, especially from the magnetic North Pole, which, by the way, now is moving at 45 miles a year. Look it up. I believe what's going on, and I'm going to say this in a nutshell because I don't want to get involved in this. I don't believe we are going through global warming. I don't believe we're going through global cooling. What I believe is happening, and I have suspected this for about 15 to 20 years, is that what we are confusing global warming with the overall Earth is warming up is that the glaciers are packing their bags and they're moving. And during this process, it causes the oceans to rise. And then new ocean glacier ice forms and the process starts all over again. Well, I was doing some research that I normally try to keep up with. And in 2017 to 2018, did you know that NASA reported over 2 million new square miles of Arctic ice? Yeah. Small little detail we're not being told about. Anyway, with the North Pole moving, and especially the radius moving, it's been moving for decades now, and it's accelerating. I strongly believe, I can't prove it, at least not yet. I believe what's going on is that we are confused in global warming for actually that various climates throughout the world are just simply shifting. Areas that used to be moderately wet are now becoming moderately dry or dry. Deserts that were once very dry, it's starting to rain. In fact, what desert, the Mojave Desert, I think it was, or I forgot where it was, but some major desert here in the world in recent weeks flooded like under 18 inches of water. Areas that were once known to be really nice climates have now either become very, very dry, like the western United States, while other areas are starting to become very, very wet. So what I'm saying here is that places that were once wet are starting to become dry. Areas that were dry are starting to become wet. Areas that were known to be very, very cold are now starting to become very, very warm, and vice versa. So what we have here is that all these climates are basically just shifting, and we're confusing that for global warming. But during this process, yeah, the oceans rise, but the oceans fall, and then it rises again. This is a reciprocal process. If you do some research like I've been doing, you pretty much can validate what I'm telling you. I just don't have the time to get the data together. But if somebody out there was to spend some time, they could actually verify that what I'm saying most likely is true. Dry areas are getting wetter, wetter areas are getting drier. Areas that are known for nice warm climates are starting to get cold. Areas that have been traditionally known as cold to extremely cold, their winters are getting shorter and they're warming up. Alaska is a good example. The frozen tundra underneath, which used to go down 18 feet, now goes down only almost nothing. The frozen tundra underneath the land in Alaska, for the most part, is all gone. But yet, we have new frozen tundra developed in other parts of the world. So anyway, all this stuff is just shifting. And I was not trying to be funny when I said the glaciers are just packing their bags and moving to a new location. I meant that. They're melting, and now they're reforming else in the world. So there are a lot of small parts to what the so-called powers that be want us all to believe that this is a big global warming problem. The oceans will eventually start to recede again. I don't know when. If I had to estimate it based upon new glacier ice, Arctic ice growing now, and the process it took, we've started noticing this last 15, 20 years, maybe 25. So if we're getting close to the peak of melting ice versus new ice forming, I say give it another 20, 25, maybe 30 years. And at that point, the oceans will start to go down, or before. But anyway, I've only got 11 minutes left. I'm going to go disappear, and I'll be back. Okay. It's almost 9 o'clock, so I'll wait a few more minutes here. Here's another big sheet I got out of another VCR here. I shared this with everybody last week, or I guess a couple weeks ago by now. Let's see here. But this is a pretty nice big piece. Trouble is that they have holes in them. So, but I'm figuring out new creative ways to use this. I'm also realizing, you know, what's the point of building an entire box around a magnet if you're only going to use one side? Now, there is a strong argument why that's necessary. The flux, the magnetic flux, let's say if this was a magnet, what happens is the flux that comes out here will wrap around. It just does this. Now, supposedly what happens is, if you do it this way, it wraps from here halfway to here, depending on whether the magnetization is through the thickness or through the length. Okay? But anyway, I have pretty much figured out that the flux underneath the stator has so little effect. You know, at least in the early stages of having some fun. It's not important. But on a production model, we're talking about things that, you know, goes into for commercial sale. Yeah, I mean, all the flux needs to be controlled, not just some of it. But to show that this is no longer theory, rather this actually works, I'm not worried about it. I'm just doing things, you know, in a very rough way. And remember, I'm an amateur scientist. I don't have a degree. I don't have any diplomas of being a physicist. And yet I get physicists and people with degrees come on here and start almost bad-mouthing me. You know, tell me that what I'm doing could not be possible. And so they automatically start calling me a cheater, a liar, a faker, all because it doesn't fit within their understanding, their current understanding of physics they have been educated on. Well, obviously at some point, physics books are going to have to be updated. And Murphy's Law, this third law, I mean Newton's third law that says for every action, note the key word, for every single action, there's an equal and opposite reaction. That's not true after all. Apparently it's just not true. Because if it was true, I would never be able to get this to work. Okay. One of the things before you start taking apart VCRs, and the way I'm getting these, and I'll have a lot more, I'll have a stack of them soon, and I'll continue to do this. And it's just fun to share it with everybody so people can get an understanding of what we can use in here. Put an ad up in your area where you live for people to donate old broken down VCRs. I've got one lady, she's going to donate one that's got a TV and VCR built into it with a DVD player. Now, she says it doesn't work. I could care less, because when I get finished with it, it's not going to work anyway. Now, what makes it exciting is that when you get, it's an older TV. I mean, I think it's actual cathode tube. It's not a screen, a flat screen. And the reason being is that magnetic shielding was required, because when these VCRs are built into a TV and the TV is up here and you have the old-fashioned tube TVs, they emit a very powerful radio frequency field, or EMF, electromagnetic field, and it will magnetize the heads, which you'll see in here, especially once we get this taken apart. So there it is back there. You can see it way back there. There's the head back there. Anyway, so I bet you that's going to have a really nice big piece like this, maybe a couple of them. So, and I looked this stuff up online. I didn't shop too hard, but from what I'm learning, a piece of MuMetal about this size and not really even quite maybe as thick as this is pretty thick. That 38 to $28 a sheet for 5 inches by 8 inches. And that's just crazy. You know, and I would need at least 20 sheets. At 10 sheets, that's $380 approximately. 20 sheets, maybe I could get a deal. Be half a grand, $500 in American money, depending on where you're at in the world listening to me. Because there are different kinds of currencies throughout the world, but in American dollars, about $500 or $600 for 20 of these. But they wouldn't have any holes in them. But I've checked thicknesses and they seem to be pretty thin. Okay. Let's do this here. Let's have some fun. Okay. I've learned each time you take one of these apart, it's different from the last one. And some of these, the manufacturers does not want us taking these apart. Okay, so looks like we're going to be taking off the face off of this first. This allows us to take the face off. What else? Here, let me back this up. And Jan, if you're watching, or Jane, I forgot what name, Jane or Jan, thank you. This is your VCR. I really kindly appreciate it. I really do. Now let's see what's in this thing here. Okay, it's got... Oh gosh. This thing has got those special screws in it. I forgot what they're called. I don't remember what they're called. Oh good, it's gonna work. Okay. And I always keep all the parts, all the screws. You just never know. So I don't throw anything away. Whatever I don't use will be donated to the local county scrapyard for metal. We collect metal here. Okay. Okay. Oh, looks like it's coming apart already. Oh, here we go. What happens is dust, food, whatever, gets down in these screws over the years into the screw head, and so you got to really work to get the, screwdriver inside of the head started. Okay. Ooh, look at that. I don't see a plate yet, but the circuitry's underneath. Now it looks like what they may be doing here as a substitute, maybe if there's no plate, they just using the plate here that they have used to mount all the mechanical parts on, felt that was ample. And who knows, maybe this is MuMetal, but I don't know, it looks like it could be aluminum. Let me take a magnet to it and see what we've got here. Okay. Oh, that's metal. There's a magnet stuck to it. So you got a little tiny neodymium magnet right here. Camera's not focusing on it. So, okay. Okay, now here we go. I'll bet you that right there. Bring better light over here. how much you want to bet that there is a MuMetal case? So I could put one. The box is already built for us. It's already built. See? So now it's got some holes in the box, but I can. What I did is I kept the little tiny pieces of scrap of the MuMetal that I had cut off. Apparently they're not real close to me where I can show them to you real quick, but the little pieces, and I can patch over that. Okay, so we've got at least one very valuable part here. A magnet should set. Yep, it does. It sticks to it. See? It's sticking to it just fine. I'm pretty confident that's the MuMetal. Beautiful thing is it's a box. It's already built for us, and it's just the right size. Okay, so what else in here do we got? We've got a nice capacitor right here, because some of you are into pulse motors, and that's right. Here's the light on it, right here, right there. See that right there? And then let's see here. Now I don't know. I mean, some of you all are experimenting. You're all brand new at doing any of this, whether it's using solely magnets or using a coil of wire and pulsing the current from the wire that you get from the magnets, or better known as back EMF, which really is a farce, where all it is, you're generating electricity. You're putting it into a fast charging capacitor, and then when the magnet comes back around at the right moment, you release the energy that was gained suddenly onto the wheel, and it pulses for a brief moment and pushes the magnet around one more time. The process is simply repeated over and over, and that's called a pulse motor. What I have had to learn in my early stages of this, which is how to time the pulse. Just go online and buy yourself a reed switch, R-E-E-D, reed switch, magnetic reed switch. Now there's another way to do it. I'm not going to explain it. It's very crude, but there's another way to do it. So that means each time the wheel comes around to the precise spot, it'll fire off your capacitor. It'll discharge your capacitor and put it back into the system. Okay, what else we got here going on? Well, look at this. $4.95 sticker here from Goodwill. So somebody donated this to Goodwill and it ended up in somebody else's home. Now I've got it. Okay. Let's see if we get this off this face. Here we go. What we're trying to do here is we need to get underneath this metal here. I don't think we're going to find a big plate underneath here. There we go. And since we'll never be putting this back together again, it doesn't make any difference if we break things. Okay, well, anything good here? I always look for little parts, anything that might help to facilitate magnets, causing the trigger, move, especially if you're doing something like a V-gate. Anyway, okay, let's see here. What else we got here? Okay. I know this is just terribly exciting, isn't it? But for some people who are especially really young, they do find this interesting. Okay. Look at this. Ooh. Here's a nice, sweet little find. Here is, looks to be a DC motor. And it's got a nice little pulley on it right there. Can you see it? So right here, there's a pulley on it, and then there's another pulley down here. What I've always wanted to do is that there's a lot of videos online where it shows these motors being powered by the other motor next to it. And they wire the two motors together, because if you take any motor at all, no matter what kind of motor it is, if you spin the motor, it will produce electricity. And so in videos that we see, they're hooking the back of this motor into the back of another motor. And they put this belt, using the pulleys that we have in here, and create a setup. And so when they spin this fast enough, then this motor's energy will start to energize the other motor and make the other motor turn. Now, it's not quite that straightforward, because you have to put a crystal diode on it, so the current will only flow in one direction. Okay, so we've got some really good parts here. Let me get this out here, though. It's still kind of hard to work with here. Okay, here we go. By the way, I take out any and all screws. I don't care if I need to take it out or not. I take them out because it allows my screw collection to grow. And over the years, I've got a nice screw collection, and I separate them and categorize them. There are different kinds of threads of screws. Some are brass, some are just, iron. The brass screws are really valuable because they're non-magnetic. It looks like brass, but I don't believe it is. Nope, it's not brass. It just stuck to a magnet. Okay. Oh, another one here. Also, if you're into electronics, there are lots of great switches on these things if you're trying to create some interesting experiments. Now, other parts that you should collect, at least that I do, is that when I get involved in these longer pieces here, like this, these are really handy, especially if you need to bridge something. See how that is? You can bridge something and put a magnet on it and fasten it if you need to this. I believe this is magnetic. If it's aluminum, it would be nice, but I'm sure it's not. Where's the magnet again? Yeah, it's magnetic. Okay, so, but all these parts come in handy. Lots of wonderful parts in here. Now what we have here again, so we have another cogwheel here, another cogwheel here, oops, wheel like right here and here. So these are things that'd be great if you want to experiment to try to emulate or duplicate one of these videos that I believe they're fake. The trouble is, everybody's quick to say something's fake. I learned that the hard way. So I figure out the only way to know is build it yourself. I tell people, I say, instead of calling me a liar and a faker, build it. You'll see that I'm telling you the truth. Almost got this out. What is holding this in? There we go, I see it right there. And for anybody who missed it or skipped over to get to the 9 o'clock part of this video, I want to reiterate, I have no formal education in physics or electrical science. So that classifies me as an amateur, because I don't have a diploma. But I have a lifetime of study. I probably studied and played around with magnets and other components and done more in this world than people who have a degree, who eventually sit behind a desk and show others what to do. So, oh, and these tape heads, these are awesome, because this allows us, if it moves so freely that you can put a disc on this, and then you can have the disc spin freely, and then you can put little tiny magnets on the disc and then experiment, or you can turn it into a pulse motor. Okay, another one here. Also, if you look here, I'm going to show you something. This here has like pistons of a car. That's compression, you know, combustion engine. The top of this tape head has what looks to be like piston heads, but there's no compression. At least not the kind of compression that we associate with. Rather, it's compressing electrical fields that create a magnetic field. And these magnetic fields, and I'm going to show you what I'm talking about, is what makes motors work. And so, if you look here, I don't know if you see these very well, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of these guys. Oh, it goes around underneath here too. It continues all the way around, and these have a firing order, just like in a car. And each time one of these goes off at a certain given time, it in turn pushes this around. And right here, this piece in here, from what I have come to see and understand, this is actually a magnet. This is a ring magnet right here. So there's some very interesting components here. If you want to experiment with creating a different kind of device that will power its own self. So, okay. Now, what I try not to do, I try not to get impatient. Because if you get impatient, you start snipping wires short. I like to keep the length of these wires as long as I can. So I try to get into the unit all the way. And I don't recommend using a hammer when you get impatient. What is holding this in still? Something's still holding this in. Sometimes it's clips. It's not screws anymore, it's just clips. Also, these have lots of wonderful little tiny springs in them. Keep all of your springs. Later you will understand and thank me. You just never know when you need some springs that help make a makeshift reed switch. Okay, I don't see what's holding this down anymore. Okay. And those screws underneath here. Huh. Okay. I don't like trying to start breaking things open because I might break something that I wish that I could have used. Don't see what else is holding this together. Doesn't make any sense. Okay, let's try a little force. It's not going to come out. Okay. When all else fails. Oh, you know what? I bet you this pulls forward, not out. It pulls forward, I bet you. I bet you it slides in there. How much you want to bet? No, it's not sliding. Okay. There must be something back here that still needs to be unscrewed. I don't see anything. Okay, when all else fails. There we go. There we go. See, there's nothing else here holding it in, so it doesn't make any sense. It's got to have some kind of clips. Sometimes they're little tiny welds. I think, okay, this is fastened down to the circuit board, but the circuit board is not fastened down to anything. So I bet this was supposed to pull out, but it's not pulling out. So, okay. Really don't want to use a hammer again if I can avoid it. Because we're after this. This is a beautiful part right here. This is very important because that's a box made out of MuMetal. Okay. Well. Oh, there we go. There we go. Ah, dang it. Let's try these bad boys out. Oh, these work beautifully. These are 10 snips. Okay. Now, as soon as I get a few of these motors, I'm going to mount them and create some kind of circuit that's required to keep the current flowing in one direction. And then I'm going to spin one motor and see if it'll run the other motor. And we'll see if those videos are fake or they're real. Probably fake, because they've been monetized. You'll notice I don't monetize my videos. I wish I had in one way, because it would certainly help to buy more magnets. But I've got a couple magnet companies who are looking at me now, and if I show them some more progress and they see that things are actually going to work, they'll probably start giving me magnets in return for publicity. Okay, so oh boy, here's the fun part right here. Look at this. For somebody who's trying to create something for some experiment with making a motor drive another motor, here's a really big flywheel with a pulley on it. If I was to interpose this between the two motors, I probably could change the ratio enough so the smaller motor makes this spin really fast. that'll make the bigger motor move even faster, and that bigger motor will put out more current, which will feed the smaller motor again. So, I don't know, we'll see. Either we have an enormous amount of fake videos up online, or we have a lot of people putting up great videos and nobody's taking the time to really find out if there's any validity to them. Hey, I found a screw I overlooked. If I saw the screw, it might have made things a lot easier. I'll take it off because I want the screw anyway. That's why it didn't slide out. I missed one. Okay. Okay, so what we have here now, can't believe it took us this long to get this apart to this point. What we have here now, here's our Mu box. I'm confident that that's MuMetal. Even looks like it. And I'll show you, it's magnetic. Get that screw off of there. You can see my little magnet is sticking to it. So, and what does that say there on the side? Made in Malaysia. Wow. Sorry, Malaysia. I had to take your VCR apart. But it was broken down. Seen its better days. I don't think anybody fixes VCRs anymore either. Because they're so cheap, people just throw them in the trash can. Okay. So, what's it going to take to get this off of here? Now, I don't have a soldering gun set up. I'm not going to put you all through that. That's crazy. But you're all getting the idea. There's no large piece, which on some of the VCRs, I find these pieces covering the circuit board. But there's nothing covering the circuit board. And I was pretty sure that because this was so light, that the manufacturer was going to cut every corner they could to keep costs down. Okay, so what we have here, we have a nice flywheel here I'll gain access to. And what I'll do is when I get it further apart, I'll show you the parts I got out of it that seem to be useful. And what is going on here? Oh, wow. Cool. And you know what? I cannot take everybody else's word for it. There's an old saying, though, you don't get something for nothing. But we'll see. Here we go. Some of these screws blend in. You don't really see them at first till you really look. Okay. Ooh, it's just about apart. Cool. Okay, that's this here. When I'm doing this, this is tricky, I'm actually looking at my computer screen, what's my screen on the back of my phone to see what it is I'm doing. So sometimes it looks like I'm fumbling around just because I am. I'm fumbling because sometimes I can't quite make out what it is I'm doing all the time, using the screen to see. So I think that's going to free this up. Not quite. Almost, but no cigar. Okay, this is attached to the head. If I'm going to do anything, I'd want to unsolder this, but I don't know. I'll snip it. It's not that big of a deal. Okay, where do my snippers get off to? Here we go. I'm excited about the parts in here. A lot of possibilities in here. A lot of backyard parts, if you will. Does this unplug? Now some of these, if you want to preserve it, you either got to figure out how to get it to pull apart or it's soldered in. Yeah, it's soldered in. Well, I got a lot of VCRs to take apart, so I really don't think I care. Okay, here we go. And we'll cut this one close as we can up here. And what's this here? This goes to a switch. Huh. Well, that's going to have to be cut. And that should do it. There we go. Okay. Here's our box. It's got a lot of holes in it, doesn't it? But nothing that can't be patched over with small pieces of neodymium like this here. You just cut this up to patch that over. Okay. It's a nice, tightly built box. I can't build boxes that nice unless I get myself, or not if, when I get my machine shop set up. That is at least 18 months away. Could be sooner, but it's at least 18 months away. So that's going to put us way into 2020. Okay. So let's look to the other parts though here. This is the good stuff here. Some of the really nice things here. Okay, keep all of your pulleys. Don't throw any of them away. Okay. And this is a beautiful flywheel here. That's what this is. It's pretty heavy. I can feel the weight in it. Wow, that feels nice. That's got nice action on it. It stops pretty quick though. Not sure why that is. Maybe it's got resistance on it. Yeah, it does. Right here. Something's going on up in there. Okay, so anyway, you got the idea. The whole point of this was to show on video, live, what we might find in VCRs that can help facilitate building a magnetic motor. But there are other things in here that are great to just goof around with and building a motor that will run the other motor next to it, like we see in some videos that most of us, if not all of us, think is fake. I don't really know it's fake because I don't make such judgments. I just assume that it needs to be tried. And then if I find that it doesn't work, then I can tell people online I've tried it, it doesn't work. Every once in a while you will find people online who actually do go through the trouble to see if these things do work, and they prove that either they work or don't work. And almost always it doesn't. Okay, so what else do we need to go on here? What we want to do here is we want this, we want this, we want the head here, and we definitely want the cogwheels. We hang onto the cogwheels. And any capacitors, and also these rollers here are nice. Here's the motor I was telling you about. I just need to get one more of these. I'll get that from the next VCR. Oh, here you go. Got to have these pulleys right here. There's another pulley wheel. These are going to be very critical in hooking one motor up to another motor. Okay. So, okay, that's it. At this point, I think things are going to go from boring to extremely boring. Really, this is not a spectator sport. I'm just trying to show what's possible here and killing time in the process. So, okay, you all get the idea. So, and I'm not going to do anything further. If you are wondering how I build my stators, I already made 2 videos prior to this. You can go back and look at those. I have to modify the frame system I already have for my next prototype. It's come along just nicely. So as far as that's all there is the news on that. One of the things I will share with you, I'll just tell you this. I got sidetracked into magnetism years ago. because my father got involved in this. He was trying to do this. And he was trying to make magnets move and move and move and move and move and move and never stop. That was back in the 1960s, like 64, 65, when my father was trying to do that. There wasn't any web at the time. And he had this advanced thinking, could I use magnets to power other magnets to make them move in a circle through the law of cause and effect? But I don't believe he really took Newton's third law of motion or attraction head on. So if you take Newton's third law of attraction head on, it says for every action there's an equal, note the word equal, and the word opposite. There's an equal and opposite reaction. So I'm thinking here, but wait a minute, just simply make the reaction less. So the action and the reaction are not equal. I would call that unbalanced. And I just said, okay, I think I know how to do it. I whipped together some shielding, wrapped a magnet around it, had a little fun, and literally within 2 hours after assembling it, it literally worked immediately. And the magnet kept right on going, just beautifully past the magnet. It didn't come back. Like in Newton's law says it would come back as equal reaction, equal and opposite reaction. If you go to my channel, look at the very first video. I believe it's the first one I ever put up. It could be the second one. And you look at that video. Though you cannot see, it's a tight shot, very tight shot. Even though you can't look around and see if I'm cheating or see if I got something underneath the table helping me. You know, just look at that video. And that was my initial first video I made, showing that I actually indeed had overcome Newton's third law of attraction. And I made a cute little video with kids going, yay, and all that stuff in it. But it's not a fake video. It's real. It's the real deal. I mean, I really have overcome Newton's third law. Go look at it. And if you don't believe me and you think it's all fake, you don't even belong here. Why are you here now watching any of this? Okay, so I guess I'm going to close out here because the rest of this is just going to be a pain in the ass. I'm going to have to get a soldering gun. And what else? And pulling this motor off is going to be a little bit of a trouble. No, that's just 2 screws here. I'll do this real quick so you can see what kind of motor we got here. I can read you the information for those of you who are highly knowledgeable in this area. So it might be helpful information. Be sure not to lose your lock washers, because there are lock washers on this. The little tiny lock washers. They're real hard to find in a hardware store. It's not absolutely impossible. A lot of times these little screws, these little nuts, bolts, and washers, they're made specifically by a manufacturer in mass numbers for the manufacturers who put the VCRs together. So they're custom. So you won't find them anywhere except in a machine like this. Okay, got some kind of circuit board going on here with this motor. Do we care? I don't. Okay, so snip. There we go. Okay, here's our first fun little motor. Can't wait to try this out. Thank you, Jan. This is going to be fun. What's going to happen here, Jan, if you're watching? You're probably not, unless I make it so you can see just this part of the video. I'll be hooking a pulley up to that. Jan's the one who gave me the VCR. I told her when I do it, I show her what I was doing. This here will go on this pulley, and there's another pulley right down underneath here. And what we'll do here is we're going to hook this motor up, put this pulley to wrap on yet another one of these motors. But this is the only one I have. So when this motor is spun by me turning this, when I spin this fast, like this, if I was to put a voltmeter up to this, there's 2 wires here. Let me separate those wires. There we go. There we go. There we go. Okay. what happens is that when we spin this motor in a circle like that, electricity is coming out each end. So if I had a little LED light, I probably should get one. I don't know why I don't have one. Probably some of these VCRs, I'll snaggle one. And when I spin this real hard, it'll light up the LED. So the theory is, Jan, is that the electricity that comes out of these wires could in turn power another one of these small motors. And so this motor would make the other motor run. Now, it's almost that simple. I don't know if it really works because there are videos online showing that this supposedly will do it. But they may all be fake. So I will put this together. I need one more of these, and I need a crystal diode to make sure the electricity can only flow in one direction. If I remember correctly, that will be a crystal diode. Okay, so I'll get these other parts off of here. Be sure when you take this apart, snaggle your cog wheels, this stuff here. Here's another nice wheel here, and this flywheel. Oh, this is gorgeous. So, boy, it feels heavy. That's got a lot of weight to it. That must be solid. I don't know how I'm going to take that off. And I'll see how. Ooh, look at this. Ha 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 ha. Look at this, would you? Guess what's going on right here? If I didn't know better, that is an electronic read switch right there. You see that bad boy? Right there. So you can, right there. It's pushed almost touching the flywheel. So something in here, each time it goes around, it triggers this right here. It's a magnet, I'm sure. Some kind of magnetism going on here. And it generates a little field, and a little charge goes into the circuitry and tells this to do something. So there is an electronic read switch. Now, I don't know if I can capitalize on using that or not. So I guess I'll be careful not to destroy that. So, like I said, look around, check carefully, and you never know what we're going to find in these units. I guess by the time I take 20 or 30 more of these apart, I'll be an expert on it. This is only my second or third one. So, the thing is now how to get this apart here. I don't see any way to get that off. Sometimes these are pressure fit. You have to pull these off with force. So let me try that. Oh, that's a pulley. I gotta be careful not to break that up. See, there's a groove there. That's where the belt goes. The pulley is to make the playhead and the tape go smoothly, so there's no jumping or jittering. But I don't see any way to get this off. Gosh. Oh! I'm pulling really hard and I broke it. No, I didn't break it. But I'm not going to try that again. A little tiny piece looks like a real sliver broke off. But that's not the way to get this off. Aha, I think I found it. Sometimes looking a little bit first before we apply any force is best. I believe these screws will let it go. Ah, dang it. That is a really tiny screw. I've never seen screws this small in a drugstore. I mean, in a hardware store. And it's got a coarse thread on it, which is meant to go into plastic, so it bites really good. It's like there's two little tiny more screws in here. Now you're going to have to get yourself a real fine point Phillips head screwdriver. Otherwise, you're not going to be able to do this. See how fine mine is? I don't know if it'll allow me to focus that close. Let me try it this way. See? Real fine point. Okay. lot of them in here. They're recessed underneath the metal plate. There's a little tiny hole that gives us access to these little tiny screws. The screws that get much smaller than this are the screws that you find inside of watches. And one more screw here. It looks like we might have it. So basically, you're going to sit down here for however long and methodically and carefully, slowly but surely take a VCR apart. And just, if you don't think you can use a part for something, keep it anyway and just separate your parts. One of the things I started using to separate parts in is that because a family member takes medication to keep themselves alive because of their medical situation, they're on, I don't know, 4 or 5 medications that's been prescribed between the hospitals and the doctors to try to lengthen their life here to stay alive as long as they can. And those bottles, some of them are kind of big. They're actually kind of nice. So what I do is that each time we come to refill them, you know, Walmart or whoever, in this case Walmart, they don't want the bottles back. So what I do is I strip the labels off of them and I use them to collect all these little parts. And I try to separate the parts in such a way that it makes sense. Oh my gosh. Look at this. What a find. Oh, isn't that beautiful? Isn't that beautiful? Even Tesla himself would be impressed. Wow. That's quite a little work of engineering. Wow. Okay, and this is that flywheel. Yep, that's the flywheel. Okay, so remember I said that thing on the side was an electronic reed switch? Well, I think it was, I'm still correct, but apparently what that does is that either it sends a command to each individual coil, or each individual coil sends a command to that reed switch. Wow, this is quite a piece of work. Now the question is there a way that you and I can use this wiring the way they've got this set up, and we ourselves create a pulse motor based upon this and pulse this and use that switch. But remember, we're going to have to generate excess electricity to use because we can't use any outside source. So we put a flywheel in this. See, this spins? Yeah, that's the axle. Oh, wow, look at that. Oh, wow, this is independent. Oh, that's beautiful. That's so beautiful. Looky, looky, looky. Oh, my gosh. Wow, this is cool. All right, so this flywheel, and this here is a magnet. I'm pretty sure that's a magnet. I don't want to test it with a magnet because I'm afraid it'll damage it. I'll interfere with the field. So let me take a screw here, and let's see if I'm right. Otherwise, a screw will not stick to this. Nope, there's no magnetism there. Okay. So I guess next question is it magnetic? Yes, it's magnetic. My magnet's sticking to it, as you can see. Okay. Okay, so these on this side, and this is pretty thick. The distance between here and here is quite a distance. Looks to be a full 1/4 inch thick. And what's going on here, despite this long distance between here to this edge, it has the ability to penetrate all of this and make it all the way over to this side here. Where is that bad boy? Right? Get a pencil or something to point with. Right here. And that's that reed switch I was telling you about. Let me snip this from this board here. And this is hooked up directly to, gosh, it's hooked up to the tape head. I don't want to snip this, because we might want to have these two talk to each other so you can better understand the firing order, how this works. Because I think we can turn this into a pulse motor. And besides, all the hard work has been done for us. That's all I'm saying. Don't try to reinvent the wheel. Although somebody did. It was on Shark Tank. I thought it was pretty cool, but apparently it didn't catch on. Okay. All I'm doing now is making it so this here will uncouple. Oh, one more screw. Anyway, my suggestion is wherever you live or wherever in the world you might be, if you know there are VCRs around you, they break down. I mean, there are millions of VCRs broken down that people just didn't have the heart just to toss into the trash can. I found that many people still have their VCRs even though they're broken down. So I put out an ad request saying, hey, can I have will you donate your broken down VCR? And that's what's happening. So finally people are starting to donate the VCRs to me. Okay, here's the same basic configuration. Let's check something out here. Where's my pencil again? Here we go. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Count again. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. 1 dozen. 6 and 6. 6 on, 6 off. Who knows what's going on here? Okay, now on this one here, this is the question. And see, can I pull? That won't pull through. There's way more than 12 here. Maybe there's 24 here. I don't know. Let's see here. I guess let me unscrew this. I really don't want to, but I'm going to need to. I might have to put this part back together. Okay. I'm telling you, we really have something here. Because, you know, there are other people on YouTube or wherever they're at, and they're doing things very similar like this. There we go. It's not coming off that easily. Oh, here we go. I feel it coming. I guess I didn't get that other screw all the way out. Oh yeah, I did. It's all the way out. But like I keep saying, save all your parts. Get little medicine bottles, separate them. And some of these parts are way too big for, you know, medicine bottles. So you'll have to find other small plastic containers, which is what I have done. Okay. Oh, I started to share something with you all and I forgot. I was saying that magnetism is not my area of expertise. It's just an area that I very thoroughly understand. My real area of expertise is electrostatics. And I got totally sidetracked into all of this stuff. My goal is based upon what I discovered when I was a teenager, especially when my mother was walking down the hallway. And, oh, here we go. And when she was walking down the hallway at night, she flipped on the hallway switch as she had done hundreds of times before. The moment she turned on, the hallway light switch, the hallway light came on. But the hallway light only came on for but a fraction of a moment. In that moment, my mother made the most crazy, awful sound as though somebody had punched her in the stomach. And she went, "Oh!" And no quicker than she said that, my father and I naturally looked toward my mother. And if it wasn't the sound that was going to make us look her way, it was the immense, pure, white light that was gushing, pouring, radiating out from the hallway. I was sitting down on the couch, and I did my darndest to get up as fast as I could. I got up so fast that I actually fell back down, and I scurried over there quickly, which was only about 15 feet away from me, on my hands and knees. As I got to the end of the hallway, I was able to stand back up, and I saw this ball of light. And it was drifting about the size of a $50, I guess, maybe a quarter. But the core of it was very bright. But we still could look at it with the naked eye. And it was floating down toward the floor very quickly. And eventually, it started to get ready to hit the floor. As it got to the point about to hit the floor, I got real close to it and then got back down on my hands and knees and put my face almost right next to it as it hit the floor and went out. I didn't know until years later that the darn thing never went out. It actually went through the floor, but that's another story. Get this out here. Anyway, what had happened is that there were two pieces of glass. Thomas Edison's glass that makes the bulb, and then a thick quarter-inch glass shielded around it, a globe to help soften the light in the hallway. That ball of light passed through both pieces of glass. Come on, get this thing out of there. What's going on? I don't want to break this piece. Something underneath right here is forced. I can feel it. Hang on. Oh, okay, hang on. Something's underneath here is grabbing this. Something else is going on here. Okay, this is really thick metal. I'm going to see if I can cut through this. I don't know if I can or not, but I don't want to cut these wires. Anyway, after that event was all over with, I naturally had to do what? Get on a ladder, get up, take off that globe, and change the light bulb. Well, when I changed it out, I studied the light bulb. And when I studied it and looked at it, I realized how probably that ball of light was created inside of that bulb. Long story short, I figured out what it did and later was able to replicate it. And that took me on a journey in my search and understanding of balls of light, or static balls of light. It's also known as ball lightning, which is generated from electrical storms, which I later figured out how it's created. As part of the lightning bolt turns back on itself. That creates the ball of light, or ball lightning. Gosh, that's hard. I don't know if these snippers are going to cut this or not. See, this piece here is not going to pull through that hole. It's not going to pull through it. And this piece is not going to pull through it. So the only other way to separate this is to snip this or unsolder it. And I don't want to unsolder this. I don't want to damage this. This is very important. So maybe if I can snip this just enough to slip that through. So anyway, my journey got involved eventually in electrostatics. And later I learned what it would take to make these balls of lightning, or balls of light, over and over and over again. Well, the interesting thing is that if you know your physics, or basic understanding, if these balls of light are giving off light, which is what they do, what does light consist of? Photons. Little photons. And these photons help to make up the light that we see. So that means these little balls of light are balls of photons. That means Yeah, if you're following me along here and you're a Star Trek fan, if you were to create a device where you could actually set these balls of light into motion and did so in a fashion that you could create some kind of gun, you would have, yeah, a photon gun. Now, I'll tell you this. Unlike Star Trek, shows that photons, when it hits something, it blows things up. I've learned that ball light doesn't do that. What it does is energy is transferred into the object, goes through it, and comes out the other side. If the object is grounded, then the ball of light will be absorbed into the field where it's grounded. In the situation of Star Trek, if they had portrayed it accurately, it would go in and just fry their computers, but it would not blow up a ship. So, sorry people, I don't think photons are ever going to start blowing up people. I mean, blowing up other ships. But it will create absolute hell and havoc with another ship. And these balls of light curve in the Earth's atmosphere, but in space, they travel an absolute straight line. Okay, so let me see here. It's getting late. It's 10 o'clock. I don't like making these videos very long. Because if there's nothing more to share with you, it's just pointless. Where did that go to? Where did that get off to? Oh, here we go. Try one last time here. So anyway, Edison's light bulb, the way the filaments inside of the bulb work, was the secret to why and how that little ball of light came jumping out of that light bulb back in the 1970s. Always cutting it. There we go. But just don't cut as much. The tin snips will work better. You squeeze real hard. Gosh. Oh. Okay, I'm biting off more than I can chew, maybe. Or maybe I just need bigger tin snips. Yeah, this is not going to cut it. Nah, it's hardly put a dent in it. Anyway, I'm not going to continue in a live broadcast struggling with this. But the bottom line is here is that we got an amazing part that if Tesla was alive today, he'd be impressed. Hey, what's going on here? Hey, check this out. Feels like this is coming out. Oh yeah, here we go. This is coming out. Hell, I don't want to damage this. I'll fool around with it, you know, and see what's going on, what I can learn. Okay, that's it. I'm done. Pretty much everybody's left anyway. So, if any of you happen to make it all the way to the end of this video or talk about balls of light, you have any interest, I started a group on Facebook called Fun with Static or something like that, Static Electricity. I haven't been able to do anything, but in the process of creating my balls of light, I had to create a ball light generator. And there's an old saying, necessity is the mother to all inventions. Well, the static generators, friction generators that you find online were nowhere near ample. So I had to create one from scratch. So that's what I did. So I have this brand new kick butt electrostatic light bulb generator that the world has never seen. And it's really cool. It kicks butt. I mean, it just does a great job. It'll kill you too. You screw up, you're dead. Especially when you bring the capacitors online. We're talking about capacitors, you know, a couple feet wide and 3 feet tall, and having a battery of them, like half a dozen of them. And there's no room for error. No room. If I screw up and forget they're charged, or get too close to the capacitors or the discharge area, you'll never be hearing from me ever again. I'll be dead. If I live through it, it'll be a miracle. So, okay, that's it. I'm done. I'm going to continue working on this after I sign off, because I got to get the rest of this done. I guess I'm going to have to get some bigger tin snips. Otherwise, I'm going to have to sacrifice and cut this wire. I don't want to cut it because I believe this is a very important part in trying to build a pulse motor using good old-fashioned VCR parts. Because look at that. That is really sweet. And then you got the other counterpart here, right there. And these talk or communicate to this reed switch right here. If you don't know what a reed switch is, right there it is, right there. And you see it's real close proximity to the edge. I mean, you'd be lucky if you could put a paper dollar bill between this and this flywheel. It's real close. So it's very close tolerance. Maybe a thousandth of an inch, I have no idea. So I'm going to have to find a way to get this apart without damaging all of that. So, okay. Well, it's nice that nobody asked me any questions tonight because it really made my job easy. And I'm glad that everybody whomever visited, I appreciate you stopping by. But you get the idea. Put ads up online, Craigslist, on your Facebook page, wherever. Even some of the Facebook pages where people sell stuff. People are looking through there all the time. Just put up a request that you're looking for broken down VCRs to be donated to you. And you'd be surprised. People start communicating to you. They start PMing you, or if you got an email address you allow them to have, they'll start emailing you and telling you, or texting you. If you give them their phone number, if you give them your phone number, because they don't want to give you their phone number at first, and they'll text you. And they'll say, hey, I got a VCR. So they're starting to come in, got more coming in, and hopefully between all these different VCRs, we can have some real fun here. That's all it is, it's fun. Just having some fun. And hopefully some fun will lead to something very productive. Okay, that's it. As I always say, that's all the news that's fit to print here at Lake Will Be Gone. Thanks for watching. Take care.